Welcome to saitechinfo channel, my dear students. In today's session, I am going to discuss about conformations. You know something about the isomer. We have discussed in the previous sessions about isomer. We know something about structural isomer, under which we have that is a function isomer, then tautomerism, chain isomerism, and on the other side we know something about that is geometric isomerism, and we have already discussed about the optical isomerism, optic isomerism. Okay, now we are going to discuss about this is also a type of isomerism where it is because of the carbon-carbon bond rotation, carbon-carbon single bond rotation. So different forms are arising out of this carbon-carbon single bond rotation. So these are called conformers, and this phenomenon is known as conformation. Okay, look at this. So this is the methane molecule. You know, this is the tetrahedral structure of methane. Are you able to see this? This is the tetrahedral structure of methane. Okay, right. Now let me pluck off one carbon from this. Now it becomes what? Methyl group, because it has CH3. Clear? CH3. Right? So this is CH3. And let me join with another CH3. So this is CH3. Let me join this. Now what is this structure? This is the ethane. Are you able to follow? CH3, CH3. Is it clear? CH3, CH3. And you can see, in fact, that is when I keep the molecule like this, okay, straight, there will be a front CH3 and a rear CH3. The front CH3 hides the rear, the back one, is it not? Okay, so it hides exactly. So this is the eclipsed form because it hides the rear one, rear CH3. Okay, carbon carbon, you have got one carbon and you have got another carbon here. Now let me rotate this bond slightly like this. Now this is the staggered one. Are you able to see that? You are able to see all these hydrogen atoms. Okay, so likewise it is because of the rotation you are able to get different types of isomer. Okay, so this is called, if you keep like this you are able to see, but in this perspective view you can see different conformations like this. Okay, let me explain. Here it is cyclopropane. It is in the planar conformation. Okay, so cyclopropane, CH2, 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 and this is called a cyclobutane because you have got 4 carbon atoms, is it not? So CH2, 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 cyclobutane. And this is the non-planar conformation. Okay, so it is not planar. You can see the V cut, a bend like this. Okay, so this is not planar, so that is why it's called non-planar. And what about this? This is cyclopentane. Can you count the number of carbon atoms here? That is 1, 2, 3, 4, 5. So C5H10. So in each corner you have CH2, 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 CH2. And this is also a non-planar conformation. So this is the type of conformations available in cycloalkanes. Are you able to follow? Right. And what about this one? This is known as the Char conformation. Char form of cyclohexane. Can I count the number of carbon atoms? 1, 2, 3, 4, 5, 6. So in each edge you have CH2. Okay, so CH2, 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 that is C6H12, where you can see the CH bond is present in 2 ways. One is axial bonding, another is equatorial bonding. Okay, so this A represents the axial bonding, and the E which is slightly bent, that is called the equatorial bond. So A and E. Now you can see, so that is this is A, and when you go to the other edge, you have to draw downward. Okay, so this is A, upward, downward, upward, downward, upward, downward. So likewise you have to draw. And another equatorial, it should be drawn like this, that is left down, okay, and here up, slightly bent, and similarly in this way, and here it is bent upward, and here bent downward, here bent upward. So likewise you can draw the cyclohexane. You have to practice it properly, okay. And let us consider the other conformer of the cyclohexane, which is known as boat conformers. Okay, so boat, it is something like a boat. Okay, are you able to see the boat like structure? So where you have CH2, 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 CH2. So here you have additionally flagpole. The flagpole is F is called the flagpole, and S is known as the bowsprit. Okay, and X and X are the pair that eclipse the hydrogen atom. So the pair of eclipsing the hydrogen atom. So they are called eclipsing, a pair of eclipsing hydrogen atom. So these two are hydrogen, they hide each other. Okay, and you can see the other forms, other bonds also, like axial and equatorial. Okay, so this is known as the boat form. In fact, Char form is more stable than boat form because of less strain. Okay, so there are two types of CH bonds. One is axial, another is equatorial. Axial bonds, here you have 6 CH bond that will be parallel to the axis of the molecule, whereas equatorial, that subtends almost an angle about 70 degree and 110 degree with the axis. And this axial can further be divided into two, that is the beta axial, alpha axial. So 3 axial bonds are facing upward, as I already explained. So these are beta axial. Are you able to follow? Facing upward, A upward, this one is upward, this one is upward, and the remaining alpha axial facing downward. So alpha axial, alpha axial, alpha axial. So they are alternatively present in the cyclohexane molecule. Do you understand this? And similarly, in the case of equatorial, here you have CH bond subtending an angle 70 degree to 110 degree. So here 3 equatorial bond facing upward, they are called beta equatorial. So can you identify which are beta? So this one is beta facing upward, beta, and here also beta. Okay, and the other one is what? That is the equatorial bonds are facing downward, they are called alpha. So here you have the downward arrangement. Okay, so likewise you have two different, so you can, I think that is in case of Char form itself, you can, it is clearly, it is visible. Are you able to see this? This is the equatorial downward, and this is the equatorial downward, and this is the equatorial downward. So you have got 3 alpha equatorial. And what about the 3 beta equatorial? That is bent upward, and this one is bent upward, and this one is bent upward. So they are alternatively present in the ring structure. Do you understand? Right. So this is a very important thing. And here you should note down one important one, that is the eclipsing interaction that destabilizes the boat form. Eclipsing means that is they hide each other. It means they, or for instance, let us consider in this case these two are eclipsing hydrogen. Okay, so it is because of that there is a strain, and it is called the steric hindrance actually. So steric means, stereo means space, hindrance means obstacle. So there is a steric, that is a space level strain, and that is why boat form is less stable than that of what you call the Char form. So in cyclohexane, which is more stable, Char form is more stable. So there is always an interconversion. So what do you call this one? This is cyclohexanol. Okay, and what type of cyclohexanol? Here it is pointing downward, whereas its position is changed here. Are you able to see this? Okay, so the orientation should also be taken into account. So when you look at the energy level diagram, you can compare these two. For example, the one which is present axially, that has got a higher energy level. The one which is present equatorially, it occupies the lower energy level. So lower the energy, higher will be the stability. So here you can see the boat form which occupies a very high energy level, so it is less stable. Are you able to understand? So now you have the axial orientation, this is the boat orientation, this is the equatorial orientation. So among these, which is more stable? Equatorial orientation will be more stable. So likewise you can explain the the stability of a particular conformer. Do you understand? So if there is any doubt, you can ask me.